Hey everyone, today I'm going to take a topic from Module 4 of Embedded System. The topics that comes under Module 4 are integration and testing, chip fabrication, cross-compiler, debugger, decompiler and disassembler, simulator. I'm going to take the topic cross-compiler. These are the portions that comes under cross-compiler, that is cross-compilation, and the files that has been generated during cross-compilation process. These are the files that have been generated, that is list file, preprocessor output file, object file, map file and hex file. So let us go through the overview of cross-compilation. So before I explain about cross-compilation, what is compilation? Compilation means the process of converting source code to a machine code. This machine code depends on the processor or controller in which the code is going to be executed. That is, in general way, we can say that converting source code written in high-level language to a target processor or controller understandable machine code is known as compilation. Cross-compilation means this compilation process or the conversion of source code to machine code process will be done by a software that is running on another processor or controller which is different from the target processor. I know it's a bit confusing. I will explain it with an example. That is, consider a source code is to be converted into a machine code. And this machine code, this source code which is converted to a machine code is of a processor of Windows. Okay, so let the program to be executed be in Windows. So processor is Windows. So this high level language should be converted to a machine code that is understandable for the Windows processor, and this process of conversion generally in compilation process will be done by a compiler or a software in the Windows processor itself, but for cross compilation the compilation process will be done by another processor, maybe Linux or Unix. A software from that processor will be doing this conversion to a machine code that will be understandable by the Windows processor. That is, here two processors are in play. So that is what is meant by cross compilation. So cross compilation is carried out in different steps, and this process generates various types of intermediate files, and the files generated are as follows: list file, preprocessor output file, map file, object file and hex file. This is the next we are going to deal with the files. Okay, files that has been generated. First of all, we are starting with list file. We can write it as .lst file. So what is list file? All these files actually consist of certain amount of information that is required for cross compilation. So the information that is included in list file are as follows: that are cross compiler details, formatted source text, assembly code generated from the source code, symbol tables, errors and warnings detected during cross compilation process. So list file is quite a bit a huge file. So it is having several sections. The sections are as follows. First section is page header. What is page header? So as the name suggests, it is the header on each page of the listing file. That is, a file may consist of various number of pages, and each page will be having its own header. That is known as page header. What does that header contains? That header contains a compiler version number, source file name, date, time and page number. Next section is command line. Okay, command line means that it is the command line that is used for invoking the compiler. That command line comes under the section command line. Okay, the next section is source code. Source code means we know we are converting a source code to a machine code. So our input is source code, so we have to store the source code also. The source code and along with the line number will be stored or included in the source code section. Also, we are using special cross compiler directives for what? for representing certain codes like conditional codes. Also, we know source code may contain comments, or those comments may be represented using special cross compiler directives. Also, we know about the hash include file that we use in C programming language and all. So the contents of this include file also will be included in the source code section using some special compiler directives. Next section is assembly listing. So what is assembly listing includes? Assembly listing means, as the name suggests, the assembly code that has been generated by cross compiler will be stored in this assembly listing section. Next is symbol listing. Symbol listing, also as the name suggests, will be dealing with the details of the symbols that has been used in the source code. So symbol listing also will include some subsections like symbol name, symbol classification, memory space, offset, and size in bytes. All of this of a symbol included in source code will be coming under symbol listing. Next is module information section. Module information provides the size of initialized and uninitialized memory area defined by a source file. Okay. Next is warning and errors. Warning and errors means all those errors and related warnings that has been generated in the application will be included in this section. Okay. Next is the preprocessor output file, which is the next file that has been generated during cross compilation. As the name suggests, it stores a preprocessor output. So preprocessor output means which is being output that has been generated by executing preprocessor instructions in the source file. Okay. Then what is this preprocessor output file used for? Preprocessor output file is used for verifying the operation of macros and conditional preprocessor directives. Okay. And it is also said that it is valid C source file. Next section or next file that we are going to deal with is object file, which has an extension .opj file. Object file also, as the name suggests, during cross compilation each source module is converted into an object. Okay, that is stored as object file. Okay, the format of the object file is actually cross compiler dependent. That is, object file will have certain formats, and all these formats are cross compiler dependent. For example, consider a cross compiler C51. C51 supports only the format of object file of OMF51 and OMF2. These are two of the formats that is supported by C51 cross compiler. No other format will be supported by C51 cross compiler. So certain cross compiler will support only certain format. Okay. Now next is the information that are included in object file. These are the information that are included in object file, that is reserved memory for global variables, public symbol references, external symbol references, library files with which to link, debugging information to help synchronize source lines with object code. Okay, towards the next file. That's all about object file. No, one more point is there. Sorry, that is that one important point is this, that is, object code present in object files are not absolute. That is, their address or their memory is not fixed. It is temporary. So we need to make the memory area or the address of the object code to be fixed. So that is done by linker and locators. That is, it is a complete responsibility of linker and locator to assign an absolute memory location or a fixed memory location to the code memory. So from this we are going to the next file that has been generated during cross compilation, that is map file .map. As the name says, map file contains all the information needed for mapping. So where does this mapping comes? I have already told that the object code doesn't have an absolute or a fixed memory location. So we need to map this object code to a fixed memory location, which is done by linker and locator. The details of this linker and locator will be included in this map file. All the details that linker and locator needed also will be included in the map file. So map file is quite a bit huge section, huge file, which also includes various sections of list file. Before I move towards that, I will brief about what I have written here. So what it says is that these 3 points actually says that object files created are relocatable files, meaning they don't have a fixed location. So as I have said earlier, it is the responsibility of a linker. What does linker do? To link all these object files, and the locator's responsibility is for locating absolute address to each module in the code memory. So it is the responsibility of linker and locator to basically map this object code to a fixed location. So the file that has been generated by linking and locating these object files are known as linker list file or map file. This map file consists of sections, and the sections are similar, as I have said, similar to list file, starting with page header. I have already said about page header, that is the header of the page of the file. So here a header consists of linker version number. In list file it was compiler version number. Here it is linker version number, date, time and page number. Next is command line. Also it was mentioned in the list file. Command line of list file is used for invoking linker, compiler, but command line of map file is used for invoking the linker. Next is CPU details. This section is new. It was not there in list file. CPU details means details about the target CPU and memory model will come under this category. Next section is input modules. Input modules means details of the input, that is name of all object modules. Here object file will be obviously the input, so name of all object modules in the object file, library files and modules that are included in the linking process. Next is memory map. In this we will include the starting address, length, relocation type and name of the segment in the program, which segment of the program is to be mapped. That name also will be included. Next is symbol table. Symbol table means it contains the value, type and name of all symbols from different input modules. This was also mentioned in list file. Next is inter-module cross-reference. The cross-reference listing includes a section name, memory type and the name of the modules in which it is defined and all modules in it is accessed. Next is the program size, that is the size of the program that is to be mapped. Next is warning and error. Warning and error, as I have said, the errors and warnings that are generated by linking or locating. Okay, so next file is, or the final file is hex file, which is which has an extension .hex. It's also one of the important file that has been generated, which is the final file that has been generated. So in simple sentence we can say hex file as a binary executable file created from source code. Since it is a final file, it includes the machine code. The source code is converted to machine code. That machine code is included in this hex file. That is, the absolute object file created by linker and locator is converted into processor understandable binary code. Okay, and the utility used for converting an object file to hex file is known as object to hex file converter. Next, hex file embed the machine code in a particular format. As I have said, for object file, hex file is also having particular format which varies across the family of processor and controller, that is dependent on processor or controller. Two of the most common format that has been used in most of the embedded applications are Intel hex format and Motorola hex format. Next we will be dealing with these formats, starting with Intel hex file. Intel hex file is an ASCII text file in which the hex data is represented in ASCII format in lines. Okay, Intel hex files are corresponding to a hex record. Each record is made up of hexadecimal numbers that represent machine language code or a constant data. So that's about the data included in the hex file and hex record. Actually, a hex file contains of a number of records and each record is having a format which is as follows. this is the format of each record that is present in a hex file. Okay, so I will be discussing about this format in the next slide. So this is I have written it in vertically with the description of each symbol. So here full colon, the full colon will indicate the start of every Intel hex code, and the double L, describes a record length. All the field represents the number of data bytes that are present in the record. And then 4A represents the address field representing the starting address. TT stands for the record type. Okay, so the record type, basically there are 4 record type which is described using 2 bits, that is 00, 01, 02 and 04. 00 represents data record, 01 represents end of file record, 02 represents 8086 segment address record, and 04 represents extended linear address record. Next is the DD. DD means the data field or the data that is present in the record. Okay. Next is CC. CC is checksum field which is actually used to detect the errors. Okay. So this is an example. Here you can see that full colon, and down these symbols we are using some hexadecimal numbers. So how it is described, that will be explained in the next slide. So as you have seen in the earlier example, the full colon will be indicating the start of the record, then 03, next it was 03, which comes under the LL, okay, which is the number of data bytes in the record or record length. Next is the 4 A's, which is given as 000H, which is the starting address. Okay. Next is the record type TT, is also given as 00. You can see that is 4 A's are 00 and the TT is also 00. If TT or the data type is 00, that means the data record type is being there in the file. Then next comes the data that has been there in the record, that is 02, 0C and 1F. So the specialty of this data here, only 3 pairs of data has been transmitted, right? That is 6 Ds. So these data will be stored in consecutive memory location, that is starting with 0000. See, at the memory 0000 data 02 will be stored. The next memory, that is 0001 0C will be stored, and 00101F will be stored. Okay, so that's all about Intel hex format. Next is Motorola hex format. Motorola hex format is also similar to Intel hex format with some variation. As I have said earlier, it contains of hex data which is represented in ASCII format in lines. Also it contains of number of hex records, that is a file consists of number of hex record and each record is having a format. Format of Motorola hex record is as follows, that is SOR, RT, length, start address, data code and checksum. Here instead of full colon we are using XOR, or else we can write it as like this. Okay, that is S will be indicating the start of the record. Okay, next is RT means record type. Also we use T. In Intel we were using 2 bits, here we are using 1 bit, which is representing the record type. So the record type that comes under Motorola hex for record format is 0129. 0 represents the header, indicates the beginning of hex file. 1 data record with 16-bit starting address. 2 is the data record with 24-bit starting address, and 9 means end of the file record. Next section is length. Also, as I have said, it is the length of the record, but here the count is taken as the character pairs. Okay, count of character pair is taken. And starting address AAA, as I have earlier mentioned, it is the address field representing the starting address of the subsequent data in the record. Next is code data. Code data means, as I have already said, it is the data field that represents a 1 byte of data, and checksum represents the checksum field to detect the error. Okay, so this is an example. Here you can see a type given as 5. You might be confused because I have only given 4 types. So the type 5 actually comes under as a subtype under type 1, okay, which is in more information which is not needed for our syllabus. Only these 4 basic types are needed. So here it is given as type 5 record, which is a subtype of type 1 record. Next is 03. 03 is a hexadecimal. 03 indicates that 3 character pair. Length means count of character pairs. So 03 means 3 character pairs are being transmitted. Next is 0004. Here this represents this. There are 4 data records previous to this record, okay. Next is FA, that is the checksum, okay. So that's all about Motorola hex file format. And this is the end of my portion. So these are the topics that I have covered, that is cross compilation and the files generated during cross compilation, that is list file, precursor output file, object file, map file and hex file. Actually there are a lot of examples that is given in the textbook. You can go to the textbooks and also you can Google it for more clarification. Thank you for listening to my class. Thank you so much.